Back to this course, and in this session, I'm going to look at the regression supervised learning. And in the last, our last hands-on, we did data preparations, sorry, then data pre-processing, and we understood how we could make our data suitable for machine learning models. And in this module we are in now, we learned about supervised learning and regression and classification algorithms of machine learning. Now, in this session, we are going to do an hands-on, like you already know, on just the regression type of supervised learning. And if maybe you are kind of surprised or inquisitive about this, our data is the one we used the last time, so it's still the house data set. Just like I did some formatting, so I can use the trend data as part. I'm kind of splitting the trend data, so I can use it for testing. So it's just a little bit of optimization because the test data does not have a the sales price column. So I had to do this, but you don't need to worry about it. I'm still going to show you how you could show you how to do it. Now it is some this is a but and that to note, this is a different formatting. I use something that could work, and it's basically like I said in the last course, data pre-processing is kind of a feature engineering stuff. You could try to process your data anyhow. Like there's no like stated paradigm that you could use. You could use any type of style you feel like using, but make sure that it optimizes the algorithm, makes the algorithm make the algorithms perform better, be at its best use case, I would say. So yeah, so I did some optimization, so I did some processing, and yeah, and I selected some columns that I wanted to use. So we're going to look at first of all, we're going to look at sorry, uh, we're going to look at linear regression, the linear regression algorithm. We're going to use it to since we have optimized our data for a machine learning model. So we're going to use it to train the model and make a prediction. The first time we did it, so you should get excited about it. You're becoming a machine learning practitioner. Yeah, so it's something that is worth written. Yeah. So in basically like starting machine learning models, um, you need to use some low level libraries for machine learning. The one we use is Qiskit learn or sklearn. What you want to call it, Qiskit learn or sklearn. That's what we use. It's a low level machine learning library because I would say that because if you want to do some advanced machine learning stuff, you will not use sklearn. You're going to use TensorFlow and all of that, PyTorch and all of that cool, all those kind of cool stuffs that you use. So we are going to use since we're kind of entering the field of machine learning, we're going to use a low level library which is sklearn. So is basically a library that has all these inbuilt algorithms inside it. So we don't need to like implement the algorithms in our code like boilerplate the boilerplate of it. We just import the algorithms and we use it for our prediction. So it's actually very easy. So what we need to do is to tamper with the parameters and all of that. So, but those ones are not like part of this part of. We don't want to look at those ones in this session. But we'll just get how the feel of how to train the model, how it works. Yeah. So first of all, we have to import um, the linear regression model, and we use sklearn. Use sklearn model. Sorry, I think it's linear model import import the linear regression. So with this, we have imported it from the SKN library. Then the next thing we're going to do, we're going to like create an instance of it, of the linear regression we got. Like you program it, that's what you do when you're trying to like create an instance of a class. This is what you do. Let's call it linear regression, and let us um, call it. So we call the instance. So now we can, since we now have the instance of it, like that is an object of it, of the linear regression model in the SKN. So now we have to call the fit model, the fit or the fit function to the data we are trying to try to make a prediction on. So for our case, we have our dot fit. So let's save this into a variable prediction. Then fit, as you can see, the x and y. The x is the training data and the y is the test data. So you're adding in the training data and the test data, so you can find a mapping, right mapping, a mapping that fits the train and the test data. So it's going to find a group of um, um, values of number, say vectors, that 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 when you add it, when you add it or multiply it to the input, you get the output. So we're trying to find the mapping. So that's it. So we'll pass in the trend features, and we have the optimized columns, which this is the trend data. So now we need to pass in the results, that is the y value, the sale, that means the sale price. That's what we're trying to predict, as we know with the house data price. So it will now be train, then that is sale price. Sorry, I think I made a mistake. So after we've gotten this, then we think we are good. So now as we clicked on this, it has trained the data, it has created a mapping from this to this. So now if a if a particular with this model, if a particular method is called, if the particular method is called on it, on the data that represents something like this, is going to give a correspondent to sale price. So in the next session, let us see how it's been done.